Are we good? Damn. I lost some good shit. Give me a second, cause I hate losing footage. Okay, I'm live. All right. So, anyways, what we're doing is we're back in here. We're back in here. We're working on well, let's get out of here, and we're gonna put basically our motor here. But the thing is, I'm so sick of copying this feature over and over and over again. So I am writing a little bit of code that's supposed to do that. I just want to see if ChatGPT is good at this at all. You might as well do this, but I didn't really understand this. Because stepper width, what is stepper width? It's 42.32. It's kind of a, okay, whatever. We'll just adjust it. That's fine. 31. It's 15.5 though. Okay, let's just copy this. I don't think any of this is going to be right, actually. But that's okay. No declaration for... Yeah, alright, so we're just going to have to write this ourselves. But, that's okay. It is going to take longer than I thought, though.
In this video, I will show you how to use featurescript to define a very basic custom feature in onshape. First, go to the plus menu and create a new feature studio. The feature studio is the tab where your feature script will live. In the feature studio, move the cursor to the end of the code and click the new feature button. This will insert the code template that will start defining a new feature. The precondition defines the parameters of your feature. In the precondition, add a length parameter by inserting a snippet from the parameters menu. The body of the feature defines how the feature regenerates. In the body, add a cylinder by inserting a snippet from the feature menu. Now let's use the parameter to define the length of the cylinder. Commit the feature studio and return to the part studio. In the part studio, we need to reference the new feature studio to use the features it defines. Go to the featurescript menu and click the select feature studios button. In the dialog,
oh, that's old.
And click the checkmark.
I don't even think you have to do that
now
anymore.
We can add our custom feature from the featurescript menu by clicking my feature. We can adjust the parameter and commit the feature. Congratulations, you have made your first custom feature.
Yeah, that's great, but let's go back to the tutorials. Right, okay.
To cut, and one length dimension for the slot width. Now, one interesting thing to notice is that for the part to cut parameter, we can only select
slot path, edge, max pix 1. Okay. Yeah, this is simple though. What about sketches? Oh, add sketch geometry. Okay, so you're able to do all of this stuff though. To create this sketch properly, our first task is to create a coordinate system. Okay. Uh, the coordinate system depends on three things: the two endpoints of the slot path and the sketch plane. We will first evaluate the positions and orientations of these entities, then construct the coordinate system based on them. A sketch line will always be its own body in the context. We can find the endpoints of this on this body with Q adjacent, which can query for vertices of a given type that are topologically adjacent to the path. We'll store this query as a variable named endpoints. So var endpoints is query. Yeah, I forgot about this language. Yeah. Right. I like the. I mean, using is instead of a colon, it's totally fine for me. Q adjacent definition.slot path. What's the doc string for this? Can we like just look at it? So I think what I have to do is I have to go to here and just look at this. Okay. Okay, so it takes a. Okay, so I don't know what seed is. Adjacency type. That's interesting. Adjacency type.edge will return entities that share at least an edge with the seed entities. So in this case, the seed was the slot path. Okay, so the adjacency, yeah. Oh, and then this is just an optional thing to filter it again because it's convenient, because then you don't have to call filter again. Okay, this checks out. That makes sense. I can see how I would need that myself. So, oh yeah, I forgot about debug. That's great. Okay, evaluate. Okay, this was weird to me because there's like queries and then there's, and I know that they have. Oh right, this is exactly what. Okay, so we'll read that. To find the positions of these two endpoints, we can use evaluate vertex point. To specify the individual entries of the query, we can use query nth element. Okay. FeatureScript has two completely separate ways of representing entities in geometry. Queries, like endpoints, are objects which specify criteria for finding a particular entity or a set of entities in the part studio. These are specifications and contain no information about the geometric or topological properties of any entities. Depending on the context it is evaluated in, a query may resolve to one, zero, or many entities. And then 2, geometric objects like end position contain data about geometric positions and orientations, including vectors, planes, coordinate systems, and everything else. This is just data and is not and are not contextually associated with any entities in. Okay, interesting. Okay. Yeah, this is like the fundamental thing that makes CAD so weird. Qnth element used above is a function which turns a query. The value in general, the ordering of elements inside a query is not predictable. Okay, wait. So the axes of our coordinate system will be specified as 3 directions, that is, unitless vectors of length 1. The x-axis can be calculated by normalizing a vector pointing... Okay, so what we want... Okay. Okay. It's starting to make sense. The z-axis can be calculated by evaluating the sketch plane. Ew. Okay, that's fine. Alright. Calculate the x direction. The z-axis can be calculated by evaluating the sketch plane and taking its normal. Doesn't it have 2 normals? That's what I don't understand. No, because you're taking the plane. Yes, the normal of the plane is well defined, but the normal of a vector is not. Well, yeah, there's 2 options basically, I think. Wait, is there 2 options? No, there's an infinite number of options because you have a rotation around it. But in any case, yeah, so the normal of a sketch plane is well defined. That's fine. So you create a coordinate system and a sketch plane. A chord system takes 3 things. An origin position, a direction for the x-axis. So wait, would we have to... So what I would probably want to do is also just add a freaking feature parameters, query parameter. This is going to be... wait, first off, we're going to call this bot edge. And then this is going to be origin. And this, I mean, we're just gonna make the user do everything because I'm the user and I don't give a fweek. Wait, what? Oh, it's probably vertex. Okay. Right. When you say edge, vertex, is face one of them? These are all topological definitions. They're not... Point is a more geometric term, so vertex is definitely a more... I mean, I could see how they came up with the names, is all I'm saying. So let's go back to the tutorial. Okay, and yeah, an origin position, a direction for the x-axis. This is going to be a long bot edge, and a perpendicular direction for the direction of its z-axis. Okay. Great. So there we go. A sketch plane specifies the same information as a coordinate system. Okay. Creating a sketch in featurescript always involves three parts. Creating the sketch, adding entities to the sketch, and solving it. Oh, right. I forgot about the solve part of it. That's cool. Okay. So wait, can we just follow along? So in here, we want to, what is it? Var p of type chord system. Okay, let me go back because this is gonna be a process. But maybe I want to write it out. Var coordinate system. No, I'm just gonna copy it. Who cares? So we have this, and all we need to do is, I think you do definition dot. And then how do we query this edge again? Or do we have this edge? Well, we need to get the endpoints. So let's go back here. How do we get those endpoints? Context endpoints. Yeah, we need. Okay. So we have this. Oh, jeez. And then we have this. Okay. Wait, how do you format again? Whatever. So this is going to be bot edge. And then let's do the normalize. And then z direction. How did they get z direction? They got the normal to the sketch plane of is that gonna work for me? I actually don't think it will. What if I just provide the z direction? Let's just add a query parameter for z direction. Wait, let's just see if this works and put the debug in. Oh wait, why isn't this erroring? Definition.slot path is not a thing. This is going to be bot edge. Okay, so now I want to go to here. I want to look at this thing. So we have bottom edge is this. Origin is this. Okay, wait, but why did it not work? Cannot resolve plane. What? Can we go to the, is it this? Cannot resolve plane. 27. Right. This actually is what I was saying. So why don't we just add a freaking, because I don't care. Feature parameters, query parameter. This is going to be z, and it's an edge. Okay, and then this is just going to be, and then we're just going to copy this whole thing over again. So let's delete this. We're going to copy this, paste this. This is going to be endpoints z. It's going to be z. Endpoints z. Endpoints z. End position. Z, 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 z. All right, let's try that. So we're going to go back to here. I'm going to fix it. I'm going to take this and we're going to select this. Coordinate system didn't work. Okay. At line 40. Why is that? Origin is vector. Oh, do we have to like it's like eval vertex point. That's what we need to do. What does this take? Arg is map. Yeah. Okay, I'm pretty sure that that's all we have to do. So let's go back to here. Oh, sweet. But doesn't it show? I thought it was supposed to show it. Wait, oh, maybe only if I do this. There you go. Wait, but oh, see, that's what I'm saying though. It's like, how do you you can't depend on the ordering, but now my z direction is all messed up. Wait, but also this is wrong because we want the sketch plane to actually be on the other one, not this one. So we need to fix that. Actually, okay, I gotta pee. Great. So, This is less than floating point epsilon, though. We're fine with that. Yeah, so wait, we need to flip this around. So this is actually the y-axis. So this is actually y. We're going to rename this to y. So z... I hate that it's the... Wait, can we just do... How did we get that normal? Where was that dot normal call? In here? This. Yeah, we're gonna... Why don't we just do this? It's gonna be this, but it's gonna be face. Z direction 2. Let's call it that. Alright, save it, and let's look. Can it resolve plane? Why not? Honestly, this is so frustrating. Why not, though? If you have a face, the normal of any face is well defined, right? Let's see. Wait, no, I saved it. Wait, maybe it's just a weirdness. Cannot resolve plane? I don't understand. Oh, do I have to, like... Okay, fuck it. I'm just gonna add another freaking... I'm just gonna add another, This is going to be, Y, actually. Wait, no, this is gonna be Z for real. And then this is gonna be Y. Let me think. So if I do that... Oh, wait. Definition dot Y. Definition dot Z. That might actually just fix everything, right? Let's get rid of this because this didn't work. Or let's comment it out because I don't know why it didn't work. And we're actually gonna put in yeah. So let's save this and let's go back. And then if you cancel this out and we go back in, it just needs Y. Y is this. Z is... Oh, wait. Does Z have a face? Z has a face filter on it right now. Okay, let's save that. Let's go back. So, okay, so we got this face. We got this edge. That's X. Y is this. Z is this. Did it work? It still failed? Z direction 2 not found? Oh my gosh, I'm so bad at coding. So this needs to be this whole thing, right? It's I think it's just this. Let's see. Okay, great. So if I double click this, but goddamn, like, this is so crazy. How do you make sure that? Because okay, so what? That's so annoying. How do you get it to point in the right direction? Am I allowed to specify why? I don't think I am, actually. Okay. Whatever. I think we should just move on and just use negative numbers. Because I just want to learn how to sketch stuff out. Okay, so we're going to do this. We're just going to start the sketch. We're still here. All right, so let's okay. We didn't even read through this, but I think it's just so wrong that evaluate midpoint. Oh, hey, that probably works actually. Let's see if this works. Wait, what? Oh, there's no such thing. What if I just search midpoint? Oh my goodness. Okay, so I'm just not going to look at ChatGPT's code because that's clearly it's just an uber hallucination territory, which is actually like a feature, not a bug, because kind of expect something like that to exist. To be honest, if you take an edge, you should be able to evaluate the midpoint of it. Okay, let's keep going. Create a sketch. Oh, so we have the plane. Now we have to add this. Okay. Let's create a sketch plane. Diagnose the runtime error. To make a sketch in the coordinate system of an arbitrary plane, and presumably there's a very straightforward way to just make a plane from a face. Well, or wait. Maybe that's not true. Because you don't have the origin and you don't have the x direction. Okay. Yeah. Let's just see what's in there. If I type SK. Oh wait, first off let's New sketch on plane. Oh, Jesus. And this is going to be sketch plane. Okay. So if I just type SK constraint, there you go. So wait, let's do constraint type dot. Okay, here are all the constraint types. That's cool. Oh yeah. Okay. So why don't we just do the simplest thing? Let's just make a circle. Sketch functions, SK circle, center. This is going to be. Is that right? What? You gotta really type that thing out. So this needs to be okay, we need to figure that out, but this is going to be 42.32 over 2. And then this x direction needs to be and then the radius needs to be 23 times millimeter. Yeah, and honestly, we could just freaking... Okay, so we need to know how far this is. So we need to take... I think it's just going to be... It's this, right? Normalize... What's normalize? Okay, wait, why don't we just do this over 2? Let's see if that actually works. That would be awesome. So... value.center is undefined. Wait, what? Okay, wait. Let's just say var x equals this. Can I get the type of it though? Or do I have to freaking manually do a type inference? Okay, wait. Let's just see what happens if I do that. Oh, there you go. Oh, right. I need to do minus. Okay, so we're almost there. Except for that's... Oh, circles takes a radius? Oh, yeah. Okay. Okay, so we're getting there. We just need to figure out basically the way to get in millimeters. So end position is a vector. can't I just query the length? Can I query the length of an edge? Feature script query length of edge. There's probably just a Q something. Q edge Q length. Evaluate length. Oh, there you go. Evaluate length, and this is just going to be, what does it expect? An array or something? Is a map? The hell is a, oh, this is a query. And, okay, so wait, we just want to do definition dot bot edge. And then can we just add so this is going to be var len equals this, and we're going to say debug len. Can we do this? Oh, Jesus. Okay, fine. Print line. Alright, let's see what's going on here. Okay. So let's just do that. We're just gonna say len over 2. Bro, what the fudge? I don't get that at all. Wait. Either the center is undefined or it's not a 2D point. Okay, so wait, here's what we're gonna do. We're gonna say oh, you know what it might be? Maybe like that. There you go. Nice. Yeah, it was just that it was like a meters times meters thing. Okay, sick. That looks right. Oh, man, we're getting close. That's cool. So now we just need to do that 4 more times. Okay, so we're going to say okay, so now all we have to do is and we'll get that value, but this is going to be and this needs to be times mil. Okay, but we need to wait, let's just see if this works. But I think that this probably will work. Never mind. Oh, duplicate ID. Wait. Circle 2. Oh, there you go. Perfect. So we just need to do one, 2, 3, 4. Okay, so this is going to be 3, 4, 5. And this is going to be wait, let's just do this all with plus. So plus 15. Wait, let's start from the top right and go clockwise. So this needs to be minus. So let's just take this plus this needs to be, this is good. Then this one plus minus 15 plus, and this is going to be minus 15 and minus 15. Okay, now we just need to change this. Surely there's a better way for this. Okay, so then now we say bar mount hole radius is equal to, and what actually is it? Wait, why is this erroring out here? What is going on here? Okay, whatever. So we're looking for stepper hole, stepper mounting hole diameter 4.4. Okay. Oh yeah. Wait, why did these look small? 3.4. Wait, what? I'm pretty sure this is wrong. I'm pretty sure 3.4 is wrong. I don't know. Wait, can we look at this sketch? What the hell happened here? Wait, wrong sketch. That's goofy AF. I don't know why I put M3 hole there. Because it's not. Well, at least I don't think it is. Okay, so now we just need to figure out how they do the... Alright, we're almost done. I should make a repo where I put my feature script code. Okay, so this... Okay, that's all the stuff. But, contains point... Query sketch region. Wait, why do you... What is the doc string for this? Wait, what does he do? He does it after the solve sketch, right? Op extrude. Direction, Z direction. I think that's correct. There's probably a flip argument to that. Op boolean. Okay. Wait, why do you do that? Wait, what? What the hell? That's weird. You take an extrude and then you op boolean the extrusion with part to cut. They have a. Let's go back to the precondition of this script. I think it's in here. The preconditions. Can we? Isn't there just like the full code at the bottom? Okay, so the preconditions are the part to cut. So we'll probably have to add that. I'm fine with that. I see no issue with that. I mean, we do have hella. We do have hella arguments that are totally unnecessary, but it's okay. Okay, let's go back to this, and it's okay, we're right here. Okay, we want sketch 1. Oh yeah. Q contains point. A query for all entities, bodies, faces, edges, or more. Okay, can we let's just look at that. Let's save this. And we're gonna go back here. I'm gonna edit this because we don't have a part to cut. It's gonna be this body. So I think we're good there. And we want to look at this. But query resolves to nothing. I think it's because of this Q sys origin thing or whatever it is. Which one? Wait, a query for all entities containing a specified point. A query for all fully enclosed 2D regions. So wait, we want to do what we want to do is just this. So we're going to get rid of this. Because I think that's all. I think that's. What? Oh. There you go. There you go. That's it. But what we wanted to do was. Oh no, that's it. We're good. That's great. That's so easy. Just all of them. Yeah, the learning curve is kind of high here, but I feel like once you start to understand, it's not so bad. Okay. So the next step now is to just do the extrusion, and I guess we're going to do this. We can just copy this code, right? op extrude. Region to extrude. Z direction. Excuse me. I don't know if that's right, but I think that we got it. I think we're ready. Let's see if it works. Oh, hell yeah. And then we just need to clean up by deleting the sketch, or like hiding the sketch or whatever. Oh, hell yeah. That is gonna make my life so easy. I feel like I want to do it for the gear hubs now. Dude, featurescript is actually goated. Wow. That was not that hard. And we could add more parameters just to like to make it a little more general of like, yeah, maybe you don't want it in the center, but for now I'm just gonna leave that as is. I'm gonna probably put that in GitHub right now. I'm geeked up, bro. That was fun. That was good. We can just make a new repo for it. I don't really care. Wait, what is FS? What does it think FS is? How do I know? No, dude. .fs. What do they call it? They actually have a file extension? Really? Surely it has. Surely it has a. Let's see. Is there a? Well, I don't care. I'm just gonna call it .fs. Feature script. Who cares? Okay, cool. All right, sick. Okay, what's next here? We want to keep moving on. Like, now that we've done this thing, we can close it, right? And we can just get back to work. All right. Sick. So now we have. Oh my god. Okay. So so the idea now is we're going to put a motor in there. So when we go to here, we want to replace the instance of, we're going to replace this with it's going to be a worm top stepper bracket. Great. That was easy. Now we want to take this thing and look at its, can we see its, we kind of want to move them as a group, but, you know, that's going to be, well, first off, let's just take this, what is it? That's this. Let's just take this and delete it. And then we're going to take this, and do we get to see, oh yeah, here you go. Well, no, but that's not what I want. I want to see what show mates. Kind of hard to tell. Wait, actually, if I click on that thing, it's probably this, right? So just delete that, and now I can move this around. Okay, great. So we want to mate that to, why is it not to that? And we just need to flip it. Flip it, we flip it, we flip it. Sick. Okay, so that's going to be an issue for sure. We can just lower that down. We can lower that down by a lot, actually. So we'll just do that right now. We'll make it like it's this feature. Probably this. Let's make it just, let's see if 40 is good enough, but I feel like 40 might be too low. Let's just add a couple more. 42. Okay, now if we go back to our here, it's close though. We can just make a very big diameter Yeah, we could just make a very big diameter worm. The issue also is, oh, um, okay, yeah. So we actually want to go modify the feature script to make it a little bit more custom because we want it to be, let's see, what's the, if I click this to here, the min dist is 3. I think we could get away with if we move this. But the problem is that we have to account for the socket head diameter. Honestly, though, we could just forego even we could just forego we could just put two screws in. I feel like that's fine. So what we're gonna do is we're gonna go back to features. Oh, but now my Git repo, it's actually gonna be a pain to, because it's so much easier to edit it in here, kind of. All right, I don't really care. So this, let's just rename this to be. Okay, so in here we're gonna add a parameter that's a length. Feature parameters, length parameter. This is going to be the X center from origin. Okay, and then what we want to do here is define accent as this. Definition dot this. Great, and then, oh wait, but how do we get, can't we do a default? I think there's a way to do defaults. I'll just add a comment. To do, add a default for midpoint of bottom edge. Okay, that sounds good to me. So now we need to go back to this, this, and then oh, but the interesting thing is, okay, wait, let's make it 20 and see if I do this, does it add like a, okay, it only goes, no, see how it bores through that whole thing? Yeah. Maybe we can just add a depth of, is there a way to, yeah. Okay, let's go. Oop. And then this is going to be, is there an example? Let's just do this. I don't really know. Let's just see if that, okay, great, that errored. Cut depth 5. Damn, what happened? The wrong type. What is it supposed to be? I wish there was more examples. Oh, inbound. Oh, inbound blind. Okay, so let's go back. Blind. End depth. Let's see if that works. Okay, nice. So, just kind of a wacky way to get around this, but now we can go to this and look at if it's a little bit more over center. Now the issue though is we're limited by the distance here, but how much do we need? Well, that's kind of tricky because we could move it out a little bit, but it throws off so much dimensioning. I also, let's see. This face is the same, so that origin. So if we do this and this, 21. So presumably if we change this to, wait, really? Oh, wait, but 21 plus 2.5. Okay, so 23.5. And we're going to go look at this. I think that's correct. But now we want to know the distance from this face to here. Ay, ay, ay. I mean, even as jank as this is, well, I don't even know what parts I have. I need to spend like 2 hours just cleaning everything up because I don't know. I don't know what's up to date. Okay, but I think we just want to design the worm drive. But we also need to fix the, oh yeah, and I need to buy some bearings. I should have bought those yesterday. Because there's just no way that those tiny bearings are going to work. But then part of the issue is like, let's see. Honestly, don't really have any faith in these set screw things either. I mean, I guess what I'm kind of hoping for is we make this long enough so this maybe it has like a fillet to keep it there. But anyways, this is much bigger. And it's like kind of butted up right up against this thing so that it's a little bit stronger in there. But the issue here is definitely going to be how do you minimize the distance there with keeping that gear there? I think maybe the answer is to keep this one sort of where it is. Just make it like 30 millimeters, real thick, and then we try it out. Because the truth is that I never actually tested this. I just have an intuition that this beam is going to break over repeated vibrations of these things because they're so janky. I forgot that we also have to completely redesign this to see, well, one thing at a time maybe, but like the whole point of this worm drive is so that we can put the solenoid holder on here. And I think that that will actually, I don't know. I think we might be able to do it. But I don't think I'm going to design that yet. I think we have to sort of work up to it because I just want to. The real thing is that just by today, I just want to be able to test, put this together, see what I have, and do a test. Not even with the drone motor, not even with these motors on, but just to see how easily the worm drive can lift this thing. And I feel like we're quite close to that. But yeah, we are going to need to make sure that this... yeah, because there's kind of a... I mean, we could put this over a little bit more. We also have room, not a ton of room. We also have a little bit of room to increase the gear pitch, the gear diameter here, which can, you know, maybe just like, well, I don't actually know if we can. Personally, I'd rather keep it as is. Okay, so let's just do it. We're going to design a worm drive. Dude, we should, okay, I want to get kind of cracked at featurescript, so I think we're going to do the worm drive in featurescript. Which basically means what? Can we go to the worm drive? Where is it? Yeah, this is so funny. Okay, yeah, so in doing this, we're also going to make a gear. Wait, presumably I can make features that call other features. So I'll be able to do this. Okay, so what is the idea is, okay, we'll get started on this worm drive feature script thing. So the gear hub takes a face, I guess. I mean, the thing is we started with this, but I think we want to start the other way with the helix, and then on one of these faces you make a gear hub. But I'm going to make some food. It'll only be like 10 minutes. Okay, I'm back. I'm back, ready to eat some food. Okay, so you define a, so the input to the feature that we're going to do for gear hubs is first you select a face. I guess it doesn't have to be a circle, but it needs to have, well, whatever. Anyway, then you take the center point of that face and the other, okay, so let's just say what the arguments to the feature are. The face, a diameter, a shaft diameter, and a bolt size. Oh, and a depth for the hub depth, and I think that's it. So okay, so I'll write that down after I'm done. Wait, what? Oh yeah, okay, that makes sense. It's the plus 21.16 or whatever. So what is that figure? A 60? So it's gonna be, yeah, 81.16 or something like that from there. So if I were to measure, so it's just if I were to just take this and this, the min dist is 75. Is there a way to get the center dist? Oh, I love that it draws the vector, dude. That's so nice. It's 86. What did I say? I said 81.1. Oh yeah, 5 for the wall. Okay, cool. Nice. Um, okay, wait. So, uh, the bottom of the pitch diameter is going to be this. For is going to be 41.46. Basically, I think what needs to happen is the diameter of the worm drive, or the worm, needs to be equal to the. Is it equal or a little bit less than the pitch diameter of the small gear? I'm pretty sure that's. I'm pretty sure that's what we need to do. I mean, the center of an arbitrary face is well defined, where You query all the midpoints, sum them up, take the mean. That's but I think yeah. That doesn't actually guarantee you that the midpoint is in the face. But that's fine. I mean, I'm sure that features featurescript allows you to write something where it's like just error if that is the case. You know, if you have a non what is that called? Okay, let's say I have a um oh, I don't know what the mathematical term is. I'd like to know, but it's basically a collection of points and edges that define a closed region of space. So I want to know what the term of the most general thing there is. But then also, what is the name for something that where that face could have a hole in it, meaning that it's not, I don't know, it topologically has a hole in it. The genus. Yeah, so I guess you could probably just bail if it's a non-genus zero. Uh, a genus zero surface is topologically equivalent to a sphere. I'm guessing that's also a circle. A sphere is the general name for an n-dimensional circle, I think, or whatever. I feel like for the hub, the current way that I do it is you you make a hole for the shaft, then you make a hole for the nut, and the nut goes in flats parallel to the wall, so then it slots in. But there's an inequality where uh, if the well, that goes to the center. So if the depth, so if the nuts whack over 2 plus the extrusion depth is the whack over 2 plus the extrusion depth no, basically if the whack over 2 is greater than the extrusion depth, then the nut will be sticking out above the hub. But oh, and I guess no. Okay. So that's it. So we can get started. Okay. It's time to lock in. Okay. So the first thing we're going to do, featurescript or feature studio, and this is going to be called hub. And then we need a new part studio. And we're going to call this hub. And then we want a gear. And the depth 5, that's fine. Number of teeth, fine. Module, fine. All this is fine. Let's add the center bore, and we're gonna make the center bore 5. What's a keyway? Oh, really? That's cool. Okay, so this is it. But we want the pitch. Let's make this 2. Just make it a little bigger. There you go. Okay. So, in this, the first thing we need is new feature. Then we're going to add some feature parameters. The first thing is a query parameter, and this is going to be a face, and this is going to be face. Okay, great. Now the next thing is going to be a length, and this is going to be hub diam. Okay, great. Now the next one is going to be another length, and this is going to be shaft diam. Okay, great. And then the next thing is going to be a length, and this is going to be hub depth. And then the next thing is going to be a length parameter, and this is going to be bolt diam. And we could do like an option thing where it's like if you only want to provide the but I think I'm just gonna make it I think I'm just gonna put them all in. So this is going to be nut length. Oh, we need to do nut length and nut width. Oops. And then Um, let's just make it a parameter. Okay, great. So we have most of our things. So let's just write out what it needs to do. So the first thing is create a sketch on face, on face, on face. Take the center point of face, not sure how. Draw a circle of, draw 2 circles. One of hub diam, the other of shaft diam. Both centered on, I'm just going to call this center. Okay, then we need to take the space between the 2 circles and extrude by hub depth. Okay, now sketch on top face of that extrusion. Define a rectangle. Oh, slot from center. We'll add another length. Slot closest edge dist from center. Okay. Define a rectangle of that has its closest, its edge closest to the center dist away from center. Okay, then this is like a really hard, because how do you even query for the, this is like way harder than I thought, because how do you query for the face that you're going to sketch on as you create it? Like, it's so easy to just make query arguments, or whatever they call them, preconditions. I don't know. What do they actually call them? Feature parameters. Okay, yeah. Extrude cut the rectangle down by extrude depth. This will be the center point Y height of the bolt, the set screw bolt. and nut. Okay. Then take the face created by this cut. Take the face created by this cut and closest to the center. And how do you do it? I actually don't even remember. Oh, and you also want to provide a body, probably. A face and the... Well, you could just get the body associated with the face. We'll learn to do that. I didn't learn to do that last time, but we'll learn to do that this time. And okay, wait. Let's look at... Okay, so this part is what I want to know. Oh, wait. Ah. Wait, first you do... What do you do? So if I were to roll this back here... Okay. Right. Yeah, that makes sense. So, okay. Draw a circle. Oh, wait, did I... Okay. And draw a circle draw a circle centered at the bottom edge midpoint of diameter bolt diam. Okay? Okay, then do a what do they call it? Two direction cut, where the cut towards the center is slot dist. Let's call this slot dist. And to be safe, just to make sure. Okay, so okay, then either a new sketch or... Okay, and this is going to be the hardest part, I think. Draw a sketch on that same face. That was just drawn on. Find that same midpoint used for the cylindrical cut. Find the same midpoint that was used for the cylindrical cut and draw a hexagon that has a constraint where the bottom corner adjacent to the face, well, it has to be. The bottom corner has a midpoint constraint with the, and let's just go here and go to small gear, and let's just see. It's this sketch. So the bottom corner and the midpoint, there's a midpoint constraint between one of the faces and the bottom corner. That's what we want to say. And one of the edges of the hexagon are midpointed. Okay, then, oh gosh, this is actually such a hard feature to do. What the heck? Okay, then do an extrude cut one way from, oh, and you know what? It's easier than finding the face to just use the parameter to of this hexagon outwards by nut width. And then that's it. That's the whole thing. Unfortunately, that's gonna be tough. Basically, the thing that's unknown to me that I guess we're gonna have to figure out is how you refer and specify geometry generated by the feature. Surely there are features that do that. Surely. Okay, I guess we just get started. So now that we're here, what we're gonna do is, do I need to rename this? Hub. This is gonna be, whatever, hub. So we go here, and we add the hub feature. We select this face. We say the hub diameter is going to be 25 millimeters. The shaft diameter is going to be 5.5. The hub depth, let's just make it 20. The bolt diameter is going to be 5.5. The nut length is going to be, oh, and so here is where it's kind of annoying because you'd rather just provide the bolt diameter and know that for an M5, like, so you specify M5 and then it does it. But let's just say, let's just go to let's just go to my, the flats distance is 8. The depth is 3.8. So we're going to make it 4.2 and 8.4. 8.4, what did I just say? 4.2. And then the extrude depth is going to be 12.5. And then this distance is going to be I don't know, 7.5. Okay, great. So now we at least have all of our parameters set. Let's just try to, okay, I think it'll be easy for me to do the, wait, can't we just do this? Sketch, create sketch. Can't I just, okay, let's just see what happens. Oh. No, that should be fine. Yeah, there you go. Perfect, okay. So we're getting there. Okay, you make this sketch. Is there a way to take the face of a... Maybe we can just provide the center point. Okay. Wait, which face did I pick? I picked this face. But there is no point there. But presumably I can... Okay, wait. We can make it an edge. Wait, we can make it an edge. Is there a way to get the edge type? Okay, let's just... But presumably there's a way to like ask. There's a way to ask if it's like a closed curve or whatever. There's got to be an edge type. Because isn't there like a body type? Let's see, does that fail? Yeah, you can't select this thing. Maybe it's like an empty filter. Like nothing satisfies that. Okay, wait. Let's just see. What were the other ones? Um. Center point of edge feature script. Yes. Okay, this sounds right. Let's see. Let's see if we can do it. Definition dot wait, start vertex? Wait, what the hell? Um let's just see if it works. Instead of this, it's going to be center. Oh, nice. There you go. That's perfect. You get that center point. So we assume that what you already have, but that's actually not good because there are a number of cases in my own design where the gear is closed, doesn't have a shaft hole, but the hub. So, anyways, we need to figure that out. Somehow we need to compute the center of a face. Okay, I'll be right back. Alright. But yeah, I feel like just to get a rough draft down, we might as well just cheat a little bit and assume that there is that center point. Obviously, okay. So, okay. So is this a point? Presumably that's a point. I don't even know what a point means, but... Oh, wait. Oh, yeah. So the center is going to be cent. Let's just see if this works. I feel like this might fail for some reason. So let's just make this 2. Yeah, why did this fail though? Center is undefined. Presumably, let's do this. Presumably this is false. False. Wait. It's not a 2D point. Whoa. It's not a 2D point. It's a 3D point. Let's see. let's say you have a plane and an arbitrary point. I'm pretty sure there's always a way to basically you find the shortest vector from the point to the plane. And by definition, the shortest thing is orthogonal. So I'm pretty sure if you have any point in space in a plane, then there's a way to generate a point on the plane. So, okay, so let's look at the code again. Let's see, if I go to standard library and search up use. Oh, that's great. Projects curves on a face. Is it just called op use? No, sketch use. Feature script use. Project point to face. To the plane. Oh yeah, here we go. Oh, there you go. Okay. Let's just try this. First off, do we have a plane? I think we only have a face, but let's see. Create plane from face. There's got to be a way to make a plane of a coordinate system. There's non-planar faces? Returning a 3D point on the... No, bro. I want to... Damn it. I wanted a 2D point. Surely there's a way to do this. Surely there's a way to do this. What about... Wait, did I look up featurescript center of face? Dude, I want to look into all these. These are so sick. I'm not seeing anything really. Is there just an Eve center? Eve. But what if I just look up center? Return the center of the bounding box. Damn it. I feel like there's got to be wait, what was this? Given it a face, calculate and return principal curvatures. I would expect there to be a way to... Hmm. Oh, yeah. Is this everything, though? Let's just use that freaking centroid. Value approximate centroid. But I don't even think we get a, returns a vector. This is going to be a freaking 3D vector, though. Okay, what about this? Feature script. Wait, how did it import this? Dude, I told it not to do that. I didn't ever told it to do that. Edge is so stupid. God. Hold on. Now I gotta check something. What other crap did it steal from me? No. They're scum. Microsoft Edge is scum. Okay. I randomly hit some sort of key and it just decided to be absolutely cancer, bro. Okay. I don't even know how to turn that thing on. It was just so random. You get a plane. Okay, let's just move on. We can't spend all day doing this. So this is gonna fail though. So let's just do. Wait, hold on. Let's just assume the part is like centered. Oops, what the heck? I don't even want to do that centroid thing because I know it's not gonna be right. Oh wait. Okay, this we can get rid of. Okay, so now there's a lot to learn here. Okay, so this circle is going to be of definition.hub diameter. This guy, oh wait, over 2. This guy is going to be, definition dot shaft diameter over 2. All right, let's see just where it put him, because I'm guessing that, let's just make sure that it, oh, there you go. I mean, it did it, but I think it's just sort of a lucky guess. I don't think it's, yeah, it just so happens that I put everything in the center, but so be it. Okay, now we need to take the center point. Okay, yeah. Okay. Put this here. Yes. So now, I wish there was more tutorials. or query functions. I'm trying to think about what that operation is. So I think what I could do is, wait, let's just do sketch region. A query for all fully enclosed 2D regions. Var q equals this. And this is going to be, wait, what is that second argument? Specifies whether to exclude sketch regions fully contained in other sketch regions. Let's say, let's just leave it like this. And then let's debug context q. And then let's see, did we get anything? I'm pretty sure that wait, why did it do, oh. Okay, let's just do the op extrude. Entities is a query. Yeah, let's see if that works. That'd be cool. This is going to be definition.hub depth. Let's see. Okay, great. Yeah, but we're gonna have to fix that. Oh, and it needs to be a join. Let's see, what else can I do? Oh wait, let's wait, can I evaluate owner? How do you get the body associated with a face? Feature script body from face. How do I, what the hell? Every face edge and presumably there is a way, but for right now, we're just trying to get things done. So we're gonna just add a new parameter called a query parameter. And this is going to be body and body type and this is going to be part. I'm just gonna call it part. Okay, so now we have part and we are just going to do the op boolean tools. What does that take? It's a list or something? Oh, Q union. This is going to be What does this return? I don't know what it returns. Oh, Q created by extrude one. Yeah, perfect. And definition dot part. Let's see. Does that work? That would be so sick. Yeah, I didn't think so. Oh, wait. Wait, what went wrong? Boolean bad input. Oh, that's just probably because of this. Nice. There's one part here. That's sick. Dude. Hell yeah. Okay, but now we need to... how do we now... We now need to get that. We now need to select the top face of... I'm down to just depend on the freaking index, just to get done with it, and then once it's like done, I'll post on the forums like how do I make this better. Um, okay. Okay, yeah, when I sketch, let's see. When I sketch on here just manually, but that's the origin. I wonder if this wasn't on the origin, if it would... I mean, there's still a concentric thing, so presumably within a sketch plane you can query for edges and faces. Because we could just create a plane. Yeah, why don't we do that maybe? Well, let's look into seeing if we can find this face from the extrusion, but if not, we'll just make a plane that's offset from the face of that face parameter by hub depth, because that's the equivalent way to do it. I kind of just want to do that. That seems so easy. Let's just search the standard library for offset. What if we just debug this? Q front plane. No, I don't think that's what I want. Okay, so what we want to do is try to unwrap the coordinate system from the face. Well, we have plane, so P dot plane to coordinate system. But we need to unwrap. We need to get. Let's see. Is there? Let's just try this. No way that works. To world from world. Plane. How do I get something from a map? I don't know JavaScript. We want the origin. Yeah, so all we need to do is change the origin. The origin Z. So, okay, wait. How do you get... There we go. Here we go. That's what we want to do. Oh, you can do dot. Okay, so we're going to do dot origin. We're going to print the origin. Oh, come on. I don't know why it didn't... Oh, wait. Let's just do this. Let's see here. Z is 0. This is of that face, really? No, this Y. Oh, yeah. Okay, that's super annoying. But in any case, we're going to take this origin. Oh, wait, this isn't a plane. This is going to be... Then what we're going to do is we're going to say var... Oh, wait. Plane. The normal is going to be... Wait, let's just do this. Let's see if that works. That would be crazy. Didn't think so. What happened? Cannot add value with units and number. I think we just need to do this. What? You really can't add unlike units? Dude, that's a kind of interesting design choice. Um, $61, right? Come on, man. Come on, man. Come on. I don't understand that. Oh, wait. I think, no, because hub depth is already in. Wait, what if we just do this? Wait, actually, can I do just O dot? I don't know. I wonder if we can try this. I guess this fails. Oh, I guess it worked. Did it work? So, but, wait, but I want to debug the new plane. Went the wrong way. Hell yeah. Okay. All right, sick. Okay. We can do this thing. So now on this plane we want to rock. On this plane we want to rock. On this plane we want to rock. We want to rock. So now we want to do sketch, sketch 2, and then this plane is going to be, do you have to give it can't I just give it P2? Oh wait, I think it needs to be on plane, right? Okay, so let's just delete this. On this plane we want to rock. On this plane we want to rock. Sketch 2, circle 1. So the center is going to be at 0, 0, but I want to just keep this right. And the radius is going to be shaft. Oh wait, yeah. It needs to be def dot shaft over 2. What happened? Oh. The weird thing here is, you know what I think I'm going to do? I'm just going to make 2 different sketches. That's, I think, what I do for real. So we're going to do, copy this. This is going to be Q. Oop. Sketch 2, extrude 1, extrude 2, entities Q2, Q2, definition. It is going to be hub depth. Let's see. Did it make the hole? Oh, wait. Does this fail? Wait, what just happened? Okay, so this worked, but we need to flip it. Oh, can I invert this? Can I just do this? Okay, so now we need to do a freaking op boolean. We need to copy this op boolean. This is going to be boolean 2, Q created by extrude 2, definition up part. I don't know. I think this might be the what happened? Cannot resolve entity. First off, can we just debug a query? Let's see. Is there a debug for just an ID? Wait, body? Yeah, can we try this? Oh, well, that's right. So we just need to figure out Boolean operation type dot but I think what we want to do is we want to go like this. Is this a what's happening here? Cannot resolve entities. Oh no. Oh no. Oh no. Oh wait. Oh, if it's subtract. Okay, the target. Okay, yeah. The tool is this, and the target. Is it targets or target? Targets is definition dot part. Okay. Damn it. What happened? Still? I don't get that. Op boolean. I know it's a query. The tool body is also a query. Oops, why did I do that? The operation type is subtraction. We'll remove all of the tools bodies from every target body. feel like I kind of want to read, because is this really what they do every time? Is that an extrude cut is actually just an extrude with a Boolean? I could see it, but also I'm just confused why this doesn't work then, because I feel like I'm calling it correctly. Could not resolve bodies. Process new body if needed. Okay, so can we just go to the actual tutorial and see? This is literally the exact same thing that I'm doing. So why are we getting cannot resolve entities? First off, I don't know what this is about. I think we need to do keep. Wait, can we do a Q created by extrude 2? So wait, if I let's what happens now? Right, so okay, so we have two parts. We want to okay, I think what's happening is we want to do this. We're going to do Q created by ID plus Boolean 1 entity type dot body. I'm pretty sure that that is what we need to do, because no, still no. Because Okay, so we know that this is a thing. Now I want to copy this and I want to paste this. I want to change this to Boolean 1. And I just want to take a look at that. Wait, let's undo, let's comment this out. And let's see what is going on here. I am confused. I mean, literally, we just need to do this is exactly what we need. We need a Boolean to subtract. The tools are this, and the targets are this. And that's it. That's what we need to do. So just roll this bad boy back, because we don't want that. Let's see if we can make this extrude 1. Oh, wait. Yeah. I'm gonna comment this out. Let's see if that works. Oh, there you go. Good stuff. Okay. It is kind of confusing, honestly. But I get it. Like, definition.part is gone. It's in the past. Okay, but now we want to just make our new... Alright, we're chugging along, guys. I know this isn't like there's many bugs, but this is not bad. So, here's what we want to do. I'm going to copy this. Change. Dude, I wish they had Control D. Or I wish they had multi-cursor. Sketch 3. Sketch 3. On the same plane, we're going to delete this. I'm going to sketch 3. Okay. And then SK rectangle. On sketch 3, rectangle 1. So the first corner is going to be at, so it's going to be at definition dot slot dist, and then this is going to be definition dot nut length over 2. And the second corner is going to be at, and then this needs to be, I think we can just get rid of that. I think we can get rid of that. And this is going to be definition.slotDist plus definition dot nut width. Then this, oh, but this is going to be, yeah, that's right. And then this is going to be, and then let's do a little debug on there. Debug context, how do you do it again? It was in the tutorial. Debug. that's it. Oh, wait, slot. Why slot this? So we want to just change this to be 5. Nice. That is so sick. Get me real crazy. Get me real crazy. I wanna be crazy. Okay, so now we can just extrude this. So we need to copy all this again. Oh, and then we're gonna need a. Is there actually an op mirror? There's got to be. Presumably, there's a way to mirror in featurescript. Oh, there's just a mirror. It's just called mirror. Wait, what? Wait, I'm so confused. Wild. Okay. All right. So there's just a thing called mirror. Let's. All right. Let's just do the extrusion. What is going on here? Wait. Why is? Oh wait. Okay. Actually, this is one of those weird things that I forgot about, where it's like there was like a sweep function, but it doesn't exist in here. I forgot about that. So similarly, there's no op mirror, but there is an op sweep. So we're gonna have to figure that out. But when the time comes, because the problem is you can't have a the set screw on only one side because you put too much. You just put too much horizontal stress on the shaft. It's no good. Okay, so let's just copy this. It's gonna be this. This is gonna be. Wait, format this. This is gonna be extrude 3. This is gonna be Boolean 3. This is going to be this is correct. This needs to just be extrude depth. And then the entities needs to be yeah, we can make it Q3. And then the tools are going to be Q created by extrude 3. And the targets are going to be this. I think that's right. I think we're all good. Let's see if that worked. Oh, baby. Oh, baby. But the question is now, we need to get this point. We need to make a circle. So now we need to... We could just compute that plane, right? We have the z direction. The x direction is... Yeah, because we're coding this in such a jank way that I'm really not going to be able to use it for much. What if I do a Q created by on the Boolean? I wonder if what that returns. I just want to debug that. Var foo equals Q created by ID Boolean 3. And then I think that's optional. I think I can just get anything. Or do I actually need to... Wait, don't take me to the source, bro. Take me to the docs. Take me to the docs, family. Take me to the docs. All right, can we just do a debug foo? Okay, here you go. Query resolves to 12. Oh, it's nice that when you print that out. That's actually so nice. 12 edges, 5 faces. Let's count that out. That's actually correct. 1, 2, 3, 4, 5. And then 8 vertices. That's also correct. And then 12 edges is also correct. Okay, that's awesome. 1, 2, 3, 4. Wait, 1, 2, 3, 4, 8 plus 4. Yeah, okay, 12. Nice. Okay, so how do we want to do this? The first thing to narrow it down is to just do I wish it would give me the colors. I like when it's red. But I mean it knows it's these. So now how do we select? But isn't it an array? I don't, you don't just have the geometry. We need to evaluate. Okay, so let's go back to the tutorial. What's going on here? It's similar to the endpoint thing. Evaluate vertex point. Presumably, we still need to compute that origin point. But it needs to be all in reference to the face that we selected as the argument. It just takes some time, little bit of acting. Everything will be just so. Let's see here. Let's see here. We need to we need an evaluate thing. That's what I think needs to happen. Is it, or should we? All right, let's try the evaluate. But I feel like so evaluate query returns an array. Okay, I want to just do that. We're just gonna say, oh my god, oh my, bro, these freaking editors drive me crazy. Var eves is equal to this, and then this is gonna be foo, and then we want to. What? Oh, delete does not put it in the freaking. That's crazy. That's wild. That's very wild. Okay. But can I, so what's the type of this? All right, we'll about to find out. Let's just debug 0. How do I highlight it though? Let's try to make a plane on this. Is there a way to make a plane from a face? Can I do that? Eve plane. All right, that should return something colored, right? What? Oh, you know what? It's that. Oh, hey, hey, that's the first one, and that's the right one. That's really cool. Yeah, that's really nice. Yeah. That's really freaking cool. That's really freaking cool. All right, so now we just need to, and since we know the dimensions of this cube, we can just put the circle at, okay, sick. All right, dude. Yes, let's go. This is actually becoming not that hard. I mean, I feel like we get lucky with this. Like, this is sussy baka. Okay, so now we need to copy this. And we need to go, first off, this is going to be sketch 4, 4, 3. Okay, circle, sketch 4, 4, circle 1. The center is going to be at, wait, can we look at that plane again really quickly? So, I think it's hard for me to tell. Clearly that's Z. but I can't tell what. Well, we're just gonna find out. I think it's clearly Y. It's got to be Y. That's got to be Y. I mean, it's a square. I really have no way of knowing. But we're going to put this at Y extrude depth over 2. So this is just going to be, first off, oh wait, no. And the radius is going to be dot bolt. This is going to be dot extrude depth over 2. Let's see. Why did that fail? I think maybe I can just do this. Oh, you know what? You know what? Oh, wait. I'm pretty sure I just need to delete this because this already has a unit on it. Yeah. Oh, so that's why. So we just need to swap it around. Perfect. Okay, now we just need to do this again. Dude, this is so easy, bro. Get off, bro. Easy AF. We actually need to do this is going to be definition dot slot dist, and then this one is going to be hub diam, and then this is going to be boolean for extrude 1. I'm pretty sure that's it. Please work. No freaking way. That is so exciting. Can you believe that? That's all it takes? Let's get rid of this debug. Look at that. I mean, this is very close. Okay, we just need to make one more sketch and then we mirror this and we're done. Well, we're basically done. I mean, I think there's probably a bunch of bugs related to the fact that I started at the origin and I'm relying on that in places. But still, this is so nice. Okay. How long have we been? 3:30. 3:30 for 2 of these things is actually pretty good. I feel like this is going quite well. All right. We just need to make a new sketch and basically do the exact same thing here. Okay. Hold on. Yeah, so this is 5, 5. You can delete this. 5, 5. This is going to be this is going to be not width. This is extrude 5. This is Q5, 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 5, 5. All right, so there's that. We just need to now do the actual sketch part of this. So let's just format this code. Okay. This is going to be SK polygon, regular polygon. Okay, it's yes. The center is going to be at the same point as this. And the first vertex, I don't know how to use the constraints, but we should just compute this by hand. Okay, so unconstrained. Okay. So the first vertex, so this is 8.4, and oh, but actually I don't really want to find that. Well, I'm trying to think. I guess I don't really know how long the flat is. Let's just measure it. I think this is an M4. Let me go get the actual bolts or the nuts. Wait, let me just get a piece of paper. I'm pretty sure. Okay. So we have this. This is going to be flats over 2. This is the center point. And then we know, and this is going to be whack over 2. So, okay, so we can just calculate this. So this is going to be, so what's the coordinate of this? It's like, I don't know. But we know this is right. So So I'm pretty sure that we just need to then... But we don't know... we don't know this angle. But we do know... Right? This gives us theta, right? So then we can just do sine theta times whack for 2. I think that's right. So, but unfortunately, that means we must provide the whack. But I'm fine with that. Do they have an ACOS? Oh, nice. Wait, is it in degrees? Returns a value. Okay, so we want ACOS of... so wait. Let's just say... okay, so it's going to be... I don't think it matters, but I don't really care. What happened? Cannot... what's going on here? I think we just need to comment all this crap out for right now. Oh, it's in radians? Okay. Wait, it's in... Wait, what? Wait, is it... There's no way. The flats of the whack... There's just no way that's right. 70 degrees? It's probably like the... It's probably somehow it's like the... Alright, I'm just gonna freaking measure it. This is stupid. So, yeah, it's just gonna be... So, instead of giving us the whack, we're gonna give us the, side len. Oh, you know what? It's because we never. Oh, it's yeah. Oh, bruh, I'm dumb. So wait, what is it though? We need to go over to um. Just always keep this open. This is 5 whack whack. It's 9. Okay, so let's just fix that to be 9. Okay, now that is way more reasonable. That is what I'm saying, bro. Okay, now that's checking out. Okay, cool. So now we can compute the Okay, so now we just need to know the y chord. Okay, so now we just need to know ba theta equals this. And now we need to know sine theta. Wait, is this a united sine? Presumably you can give it. Presumably that would be insane if you could. Wait, what? Sine theta times whack over 2. Okay, that's great. So now we need to place the first coordinate. The first coordinate goes. This first coordinate is going to be wait, okay, so the y coordinate, the y coordinate is actually the x. So, actually the x. Lamau. Hee hee. Okay, so it's going to be vector of, yes. Oh, it's going to be this. What are we talking about here? This is going down this way. So that first coordinate is going to be this minus. And then this is going to be almost positive it's this. What's going on there? Okay, I actually want to probably just do this and do this. And let's see what went wrong. SK line segment called with a solved sketch. I think I just forgot to what? $183. Called with us. Oh, bro. Okay, great. So now, oh my God, is that it? No, wait, that doesn't look right. That's not right. We need a, um, I mean, at least we got it that it was on that edge, but this is not right. I wish I could edit these sketches. This point and this point need to be coincident. Ay, my man. Okay, wait. Let's see. Feature script constraints. Okay, so then, okay, wait, I just want to manually modify it then. I just want to like toy around with it, see if I can get it vertical. Because I'm kind of close. I'm like almost there. My math is just wrong somehow. I don't really know how my math is wrong though. Can we just do minus? Did it regenerate? Did I overshoot? I overshot, right? So, okay. So check that out. It's going out. Let's change this to 1. Save it. Wait a minute. Why does that... Wait, if we look... No. Yeah. Ay. It's so deceiving. It looks like it's coming out of it. Wait. Nah, it does... Why does it look like it's... That's so deceiving. But it's not. It's not. If we look normal to this, you won't be able to see anything. But why is my math wrong? Shouldn't the first... From here... Okay, so this point is at... This. Okay. Is the angle calculated wrong? I don't think so. Is the angle calculated wrong? I don't see anything wrong. The problem is it's going like this. Like this is coincident on... But we need this to be... I wish I could just provide 2 of the coordinates or something. I think I'm just going to post and be like, hey, I'd really appreciate some help on this. Unconstrained. Okay, let's just try to do the... Oh my gosh, there it is. Wait. Wait, what just happened? Wait, what? Let's leave it with the math correct. Okay, yeah. Wait, why don't we just... Dude, I am so dumb. Instead of doing all this stupid math, we're just gonna make it... Wait, why is it short, though? I think it's because of the clearance. So let's just increase whack by a small amount. Okay, let's, oh my god, what is going on here? I want this to there. No. .3. So if I increase this by 0.3 or 0.6, that's less than ideal for sure. But anyways, I mean, that's pretty good. So we did it. We just need a mirror. All right, we'll do the mirror, and then we can keep working on the actual thing. I mean, I really despise this thing, though. But that's okay. Oh, I see. Yeah, see, I see how it went wrong because of the clearance. Yeah, you underestimate. And using an uncleared whack, you underestimate the. Yeah. All right, let's just do the mirror. But I don't see mirror. That's the crazy thing. How do mirror? Mirror across returns a transform, which takes points on one side of a plane. Um. Okay. Okay. So let's go to the onshape form. Um, what's enclosed? Wait, why don't mirror doesn't even show up for me, man? In featurescript. Okay. Okay. I mean, I'm fine with either of these, but these don't. I don't know. Mirror doesn't even show up for me. So, I guess. Okay, so I need to collect my thoughts because writing this stuff is actually way harder than you think. So let me just do I even want to write this, dude? I'm kind of tired. I don't really want to write it. I'd rather just live with it. I guess. Okay, well, what exactly is wrong with this? I'll comment. Okay. So first off, this is a public document. Copy this at this tab. Okay. Wait, let's just get this into GitHub too, just so that I have a copy of it somewhere. Where the hell is my discussion post? Okay. What the hell? Oh, do you have to just do this? There you go. Is there, wait, is there a way to just compute the... Oh. Okay, let's just try that. We're going to comment out this. I'm going to say whack. Oh, nice. That's perfect. Hey, yeah. That's great. Should I just copy and paste the whole code? Okay. I'm gonna take a break. 200 lines of code in like 4 hours. Literally, what the heck? But yeah, I mean, that's sweet now, right? Like, we have this thing that, oh yeah, wait, and, okay. The other thing was, I have to provide that stupid center edge, which I don't like. Forgot about that. I'll bring it up when it's posted. All right. Let's see, what else can we do here? We can hop back into the actual thing that we're trying to do. Oh, goodness gracious. Okay. So now, right now we want to redesign this worm drive. And we want to make the diameter like, honestly, we could just try to wing it and adjust it as we go. Because I don't really want to do math right now. Anybody feel me? Anybody feel me? Oh, damn. Okay, damn. What if we just used the worm drive? Wait, that's not what I wanted. Um, nice. I think we're good, right? I think we have the room. So let's just make another worm drive for this. So this is going to be tilt worm drive. Okay, and I gotta take a walk for a second, bro. I'm like, All right. Well, um, let's do this thing. So, if we were to just take this face and this face and get the min distance, it's 3. So that means we need to increase. Oh, but that's to that face. So we actually need to increase because we actually kind of want. So let's deselect this. Select this. 8. Okay, so let's just, instead of doing this, we're gonna delete this. Are we? No. Screw it. We're not gonna. So we're gonna do this. We're gonna do this. That. We're gonna we are gonna go to. Let's see. Do we have another? Okay, we don't need this. We're gonna go to worm drive, and then we're gonna look at how this was made. So we started with. I guess we started with the hub. All right. So this is what we're looking for. So this is okay. All right, so we made it 20, right? So if you take this and you were just, okay, so just roll back to, if you just roll back to here, this is 20, okay. We don't want the move face. Okay, fantastic. So we just need to make it 36. That sounds kind of crazy to me. Well, in any case, this is going to be 36. And let's just extrude it by 50. Okay, now let's try to do this hub thing. Let's select this part, this face, this center, the hub diameter. We need to set up the defaults. And we maybe have some configurations even. I wonder if you could do that. Have a configuration for a feature like this. The shaft diameter is 5.4. The hub depth, sure. Let's do 20. The bolt diameter is going to be 5.4. The nut length is going to be okay. Nice. Very nice. It just doesn't work, bro. Okay, so this is epic fail. So I can't fix that code right now. It just doesn't even work. Because what even happened? I didn't even know what happened. Wait, let's just try to roll this back. I'm going to draw a sketch on here. Draw a circle that's, and then we're going to take this and we're going to extrude it. Just by actually we could, well, whatever. Let's just do 1. I just want to do a test. So now in hub, when we do this, we actually want to take this center and we want to click on this. It's no better. Ay, ay, ay. How did this fail so miserably, though? I'm pretty sure it's all because of the orientation. Right, like, oh, yeah. That's silly as heck. Okay. Alright, we're just gonna, um, duplicate this is going to be a tilt form to. Why is this so slow? Okay. Okay. So here, now we just need to adjust. So we're trying to make this 36. Craziness. Okay, well, let's just see how it meshes in here. So we want to go to this thing, replace instances, select replacement component, tilt worm. Okay, that looks pretty good. Yeah, it's just unfortunate that we so when we called, so now, okay. But it's not interfering by that much. So let's just see if we can just shove it over a little bit. So when we use our custom feature, we are just going to make this 3 more. Still no dice. Oh no, there you go. Perfect. That's perfect. Oh, we jointed it wrong, but that's okay. Okay, so I think I have these somewhere. So we might as well try to go look for these parts and see what we need to print and what we don't need to print. God, this was so long ago. Okay. So, all right, I'm on a parts hunt, I guess. So obviously, this needs to be reprinted. Luckily, that's a support list thing. We need to print this because we've never printed this before. That'll be okay. I'm excited. I think this is gonna go really well. All right, so I'll be. I just gotta go find some parts. Okay. One thing I always neglect to do is label my freaking parts. So, wait, when we look at this, let's switch to this, and I want to look at this. It's 5.8. I'm almost positive that the dimension used here is a threaded insert. Okay, so we're going to put threaded inserts there. So we have this part, we have the gear and the drone holder. And then we have one of the brackets. We have the other bracket, but we can't use it because we need... so I think what I want to do is I just want to print this stuff out. So let's go back. So this, switch to... I'm going to take this. I'm going to rename this too. And we're going to export this. Okay. Oh, what happened here? I don't think that matters. I think we're fine. I think we're fine without it. Okay. The next thing to export is this piece. Oh, switch to... We're going to take this. And we're going to export it. Tilt stepper bracket. Yep. Okay. Is there anything else? I think that's it. Let's just, I want to get my calipers and just check that this height is correct. So we're going to do from here, from here to here, 106. Excuse me. Okay. All right, cool. It's the right part. So, we're ready to print, actually. Is that even true? Oh, yeah, and then we have the flywheels. I think these are, oh, yeah, let me get those flywheels. We get them all in one place. This is 92. Okay, we got the two flywheels. Let's just measure these. What did I say? 92? Yeah, these are like 92. Cool. So we have pretty much everything. I'm actually so shocked. Yeah, you really have to test one thing at a time. It's very hard to make a ton of changes. Okay. But regardless of what we do, like in terms of changing this carriage and changing the yeah, okay, we need to buy the bearings. I'm gonna buy some like 30 mil ID bearings, and then we're gonna try to make that work. Because I mean, look at these freaking toothpicks on the end of this thing. This isn't holding a drone. This isn't holding anything. It flexes just under the smallest little. I think it's, yeah. I mean, the next iteration of this, we can basically get rid of this whole thing. But nice. Okay, let me look for some bearings. $25. I don't know. What are the most common? $25. Whoa, this is huge though. These look good. $37. I'm gonna get those. Okay, let's just think about this. The diameter of the current prongs is 7.8. So it's gonna go from 7.8 to 24.8 over 7.8 is like 3 times the diameter. It's literally $10. I'm gonna buy them. $37 OD. Can we handle that? I think we can. $68. $37. We can definitely handle that. We can. We don't really have the room though to drop it down. That's kind of the issue, actually. But we could just make this taller. There's no reason to not just make that taller. We could chamfer and corner these edges so that, just in case that it's gonna rub. No. Well, let's see. Right. Yeah, because it's closer here. Oh, but no, but we don't even have to worry about that. All right, so let's just get them. Okay. So we just got some bearings. So now we can redesign for um, oh, I see. We could also actually make this thicker than 7, and so that it's just a press in fit, and then it can't. That's a good idea, because then we don't need these two pieces. So we get rid of these, and we just make this maybe 3 mils thicker. Oh no, you can't. Wait. No, you can do that. It's okay. Okay. Okay, where are we at? That's, I guess, the question. Maybe I'll make some food. So, okay, we actually did both of these things. CAD the table, we didn't really do that. CAD the power supply on the PCB. Fixed parameters, I use 2.4. Yeah, I guess we could just do that. I kind of want to start from scratch, actually, now that we've gotten some way in with it. Okay, so yeah, so we still need to really enact. I think it's in its own document, actually. How do I put the gear in here? I guess I'll make it offset plane. Yeah, so do this plane. Oh, shoot. Okay, that's okay. We need to just switch to. Oops. Oh, wait, where's the other bearing? There's supposed to be another bearing. Here. So we need to take this, copy here. And then we need to translate to. Translate. Oh, wait. Nice. That worked out really well. I didn't know about that. That's sick. So yeah, so there's the two bearings. So let's hide this stuff. Let's get this. And then we need to know how high it's going to be. So I guess these are flush, right? Do we want that? I don't know. We'll find out. You kind of want to stop her, but it's going to be okay. Oh, see, this is 80, so we have no clearances. We need to fix all of that. But whatever. Let's just from here to here is 21. So let's just say that we have a bunch of teeth from 22 to 28 or something. Well, let's see. Okay, yeah. 25 to 35. Let's do that. So that means that we want to do an offset plane, offset. Oh, and it's 25. Yeah, and we just need to flip this. Okay, now we want to sketch on here. Oops. We want to sketch on here, but we don't actually want to sketch on there. We want to make a spur gear. And we need the pitch diameter to be, what's the, so let's just say okay. What's this? The diameter of that is 80. And then the diameter of the inside of this is 90. So we want this to be like 85, a pitch diameter of 85. Let's do 84. So let's say this. If I just say 84, 84, and I say this is 2, so this needs to be 42. And center bore, let's make this 10. Let's just say okay, so we can get this measurement. 64. Let's just say it's 65. Because we're going to do a union anyways. So this is 65. Okay. So now we need a transform. Translate by line. Transform by make connectors. So we want from this to this. Great. Now we're going to transform again. It's going to be entities to transform this spur gear, and it's going to be just an XYZ. And it's, I can't see the thing, but I'm pretty sure it's, okay, it's going to be this, and it's going to be by 25. Perfect. And then, but we actually want to change this to be depth is 10. Here we go. It's kind of tight. It's kind of tight, but it should be okay. Now we just need to do this and this Boolean union. And there we go. Okay, now if we go back to the assembly, is this right? Move all this crap over. Is it this? No, it's not that. Wait, what? Oh, you know what it is? It's failed to resolve instance. Pretty sure it's this. Wait, what? Oh, is that the name that it took? That's kind of silly. Let's see if it's meshing. I can't tell. Let's do a cross section on this face. Let's come in a little bit. That looks great. The only question is whether or not this looks perfect. There's that. So it's not perfect. So we want to change that angle by just a teensy amount. So if all we do is we just shift, let's just try to shift. So we're gonna make a plane on this face. Oh, you can't make a plane on there. That's so annoying. Can I transform this though? Okay, nice. Wait, but that's not in the. That's not really in the direction that I want. Let's just say, wait, we want to move it along this. So wait, let's put it to 0. Then I want to say I want to move this. This rotates this whole thing? Okay. Just undo that. Why don't we just try to move this by one? Just do enter. Enter. Why doesn't it work? Jesus. Did it actually do it? I can't even tell. Alright, so, but yeah, it's not. Okay, that's good. But look at the backlash there. That's no good. We need to mathematically figure out this this thing. I mean, we kind of want this thing at a 90-degree angle to this. Well, is it? I suppose it is. I wish I could modify this section view. I really don't. I guess that's just how you do it. What the freak? I need to just I just want to move it back more. Oh wait, actually, can we? That's nice. Okay, see that? Okay, so we just need to get it ever so slightly more over. Wow, that's a great picture. So we want to take this guy and move him. How's that? That seems perfect. It's going to be governed by the smallest value, right? Well, it's going to be governed by this two added together. I feel like that's perfect. So now we just need to add a little. I don't know how we get that as reference though, but that's kind of how we want it. Okay. Okay, why don't I just get a pencil and paper and start doing some real math, like how everyone else does this shit. Let's see, is my print failing? Probably. Nice. Okay, let's say that. Okay, wait, can we get that back? This is pretty complicated geometry because Well, basically, you have a circle and you have a line. I mean, okay, it's actually not that complicated. You have a circle and then you have a line that needs to run tangent to it. And basically, the circle is the pitch diameter, and the I don't know what you call this when you and undo doesn't work. Great, that's great, really nice. What the heck? All right. I don't know what just happened. Okay, you have a circle and you have a line. Wait, what just happened? I feel like this why is this so far off the ground? I feel like it wasn't that far off the ground. All right, I might start it up again. I'm gonna end it right now. I'm busted.